Hello, assalamu alaikum everyone, and welcome back to day 3 of creating our own OS, untitled OS. So today, as per last day, I said that I found some sources, and I'm gonna of starting the whole project. First of all, I said that I will complete the bare bones tutorial, and I actually did, and actually made the OS. Let me show it to you. Here it is. Let me run it, and that's our first OS, the hello world of OS development, saying hello kernel world. Now let me show you what I actually did. So today I just followed the whole tutorial. I actually don't know most of what I actually did, what does each code do, but I know it from the service level. So for the next days I'm gonna be playing and toying with this portion so that I actually understand it properly. So the bare bones tutorial is for to create a simple kernel, a 32-bit kernel, and boot it. In this, I understood there are a couple of parts. The first of all, I need to build a GCC cross compiler. Why GCC? Because this tutorial focused on using pre-existing libraries and tools instead of making them on our own. That's why for bootloader we used grub, for compiler we used GCC, and so on and so forth. We can make them on our own with our own programming language and stuff, but for now we are just focusing on understanding the things and making it. So we use GCC, and now the thing is, what is a cross compiler, that you may ask, and I answered that question by reading this whole page. I learned that a cross compiler is used when you want to compile an OS from a different OS. Because if you use a compiler that is on currently on the OS, you won't be able to successfully compile the new OS. That's why you need a cross compiler. So the first step of this whole project was to make the GCC cross compiler. For this, it was kind of easy to make this. You had to install many dependencies, then you had to download the source codes and have it on a folder. The file directory that was used was at home. Like, let me show you. Let's do it here. I currently am still new to Linux commands, so yeah, I made it on home. We used build it opt folder where we did keep our files opt src and build. Opt has cross and other stuff. Address still not clear on that. Source, we have the dependencies that we downloaded, their source codes, and in my OS the actual OS is here, and build is empty, but we had another file. I forgot the name, but we did, or maybe I forgot. Okay, after making this and install the dependencies, we all we use those files and build the actual compiler using binutils and then GCC. It took much time. First they made the directory, then they built the actual thing, then they used GCC to build the actual thing for it. Here I found that they use disable NLS, so that it tells you not to include native language support. This is optional, but it uses so that we can't reduce dependencies. Then we also added with sysroot, that enables sysroot support in the cross compiler by pointing it to a default empty directory. Then we use GCC disable analysis for the same thing without headers, tells to make the GCC have only this C library, only not to sorry, it tells this is not to rely on any C library being present for the target, and enable languages not to compile all other language form ends. It only supports C, because GCC supports many types of languages, which I actually discovered while installing MinGW on my Windows. After that I built the whole thing and the compiler, and ta-da, the GCC compiler is ready. For that, to actually use the compiler, always I saw that I had to use this file at beginning, and then I can actually access the compiler. Here we used a target name i6xx I still don't know what it means, but surely I will in future. After making the compiler, the other stuff felt much more easier. You had After that you have to make three things: boot.c, kernel.boot.s, kernel. Kernel.s, and linker.ld. Boot.s is an assembly file that has the assembly code that creates the environment, so where I can run the C file that I'm going to make, which is kernel.c. I am from here, the code is still magic words for me. I understood some things like I had to make a multi-boot header so that when I use grub, it actually sees that yes, this thing is for multi-boot. It is enabled for multi-boot, because I learned that grub checks at the first 8 kilobytes, it checks if the file has those magic numbers, which are this. If he finds it, then he sees that yes, this is supportive and we can use it. Then we made a stack, and for the stack we used it such that we start from the top to bottom. We need this stack because if you guys know, while you code in C and C++, we need a stack memory, so while we actually run the stuff as much as it know. And if, as I'm correct, and building an OS from scratch, the stack doesn't exist, so for that we actually initialize the stack from here, and we start from the bottom to down, the top to bottom. And the stack is usually 16 kilobytes, I believe, and we use that. And then we start, then we assemble the boot.us using this command. And also a quick thing to note, boot.s, kernel.c, and linker.ld is in a different folder named myos. After that we have to write the kernel in C. And as you saw, when I actually run the OS, as the grub, you can see the text appeared, hello kernel world, and it is showing some kernel. It has the size and height and width. We actually have to manually adjust all of this, from the color to whatever to height and width, because as expected, everything has to be made from scratch if I use a kernel, if I build a kernel, literally. So sorry. So in here we did this. We made the whole kernel, writing it in C. We used VGA. We used VGA specific characters, and also it's C, as we are using a very minimal version for C. There are many libraries that doesn't exist here. We have to manually make them. But there are still some C standard libraries that can be found. Like here we used stdbool.h, standard def.h, and standard int.h. I still don't know what they mean, but they're here. I just understood that standard bool.h is used for bool data type. Okay, here it is. Standard def.h is to get size t and null, and standard int.h to get the int xt and unit xt data types. Okay, then we declared the colors, VJ color black, blue, and other stuff while using numbers. Then we made a lot of functions that I saw: a VJ entry color, a VJ entry. Also made a a string length function that we directly use in C and C++. We had to make it manually. We also defined the VJ width height. These are comments. VJ width height, and also a memory map that is needed. I don't know why. Then we set the color, we initialize it and everything, and this is the main kernel main void, the actual thing where we said hello kernel world that we saw in the actual text. Then we built it, compiled it. After that we didn't build the C++ one. Then we had to make a linker that links the boot.cs file and the kernel.c file together so that we can actually use it. After that, I don't understand. I didn't understand what it used. I just understood one part of one to one. It is usually people usually use 1m here. But as as the starting of UEFI instead of BIOS, instead of BIOS now. So, okay. However, UEFI made things difficult and more complicated. That's what people used to do. That's it. We will discover those things in the future. Then we compile, then we linked those two. Then we use this command to verify that does my actual file support multi-bit. It then checks the first 8 kilobytes. If it has that header, that magic value, if it gets it, then it's done. Then we had to make a config file in this way. I don't know why, but we did it. Then we made a directory, and then we made the whole ISO file and ran it using Chemo. So the steps that I used, and I think that I used, are first make the cross compiler, then make three files: boot.c, boot.s to make the environment, kernel.c, the actual kernel, and then linker.ld that links both of them. Then I had to make a config file, and I had to make an ISO file using graph. I actually had to run a I actually had to install something, I don't remember the name. And after that, the whole ISO is ready, and we did it, I guess. And this is it. Inshallah, next time we'll look forward on understanding. I'm gonna break this code and I'm gonna add many features, some features, so that I can actually understand what is happening on the hood. Still then, see ya. Assalamu alaikum wa rahmatullahi. What happened? Okay, can we exit this? Yes. Assalamu alaikum wa rahmatullahi wa barakatuh.